Hi everyone, my name is Thomas Kim. Today is July 1st, 2019. This is my 42nd episode about the future of C++ programming, C++ 2A standard. In this episode, I will talk about constant expression versus compile time expression. In C++ standard, constant expression is defined like this. Please double click this link. Please read this text very carefully. Constant expression defines an expression that can be evaluated at compile time. Expression that can be evaluated at compile time is constant expression. Such expressions can be used as non-type template arguments, array size, in other contexts that require constant expression. For example, intn1 std array size intn a1. Here, non-type template argument, this is non-type template argument, is not constant expression. So n is not constant expression. This code does not compile. In this case, constant int cn2, this non-constant, non-type template argument is constant expression. So cn is constant expression. This code compiles successfully. And there gives more examples, more explanations. But from my point of view, as I explained many times throughout my videos, this constant expression is misnomer, or it is very confusing for most C++ programmers. I suggest instead of constant expression, compile time expression. Compile time expression is the correct term. Constant expression is incorrect. I will explain why. Start Visual Studio Code. On the CPP extension folder, select Tutorial subfolder. Click this button, 042, compile time expression .cpp. Ctrl V, Ctrl plus. I will close this. Include talk play fun, output HPP, talk play fun, SS stream, auto, NL, talk play fun, NL. Please note that you have to add this line of text in JSON configuration file. Void test constant expression int main constant int size 10 int array size. We call this function and start command prompt cl ehsc std C++17 042 compile time expression .cpp fe aexe, hit enter. Sorry, cd tutorial. We should be in CPP extension tutorial folder. We compile once again. Okay, it built successfully because in static array, this is called static array. In C and C++, the element count of a static array should be determined or evaluated at compile time. According to C++ standard, size is a constant expression, so this code works. It compiles successfully. Now let's see another example. Size t, get size, return 10. Okay, void y constant expression is misnomer. Now let's see constant int size, get size, int array size. Now we call this function. I disable it. I will first disable this part. Okay. Now we build this program. We call this function. Please note that it compiled successfully. It compiled successfully. So is size a constant expression? No, it is not. Now we enable it and compile again. No, it does not work. Expression did not evaluate to constant. Size is constant. But the compiler complains expression did not evaluate to constant. What's the problem? To fix this problem, context here. Now if we try it once again, now it works. Okay? Why it does not work? In this case, it does not work. If we put constant expr, then it works. I will put like this. I will explain why it does not work. Even though size is specified with the keyword constant, get size is executed at runtime. At compile time, the value of size is unknown. The present can affect the future, but the present cannot know the value of the future. The compile time is present. The runtime is future. The size, the value of size should be determined or evaluated at compile time to reserve the memory for array at compile time. Since size is constant, but still its value is determined or evaluated at runtime. Is size a constant expression? Yes or no? Since the value of size does not change, it is constant expression. Since the value of size is not evaluated at compile time, it is not a constant expression. Now let's visit C++ standard definition again. Constant expression defines an expression that can be evaluated at compile time. So the size is not constant expression. It's very confusing. If we say it as compile time expression, there can be no confusion. I hope you understand what I'm saying. I will disable this part and I compile again. Of course it works successfully. If I re-enable it, it does not work. No, it does not work. I will fix some of my English. This is typo, misnomer. So I will copy this function name once again and paste it here. And also I will fix this part. Even though size is specified with the keyword constant, but still its value is determined or evaluated at runtime. So since the value of size does not change, it is constant expression. Since the value of size is not evaluated at compile time, it is not a constant expression according to C++ standard. Now to enable this to work, I will put context here. Now it works. Okay, it works successfully. Now let's move on. Here I declare int global int. I initialize some value, for example 10. I create a function, template function. I say int, this is address, ptr, int, get a value, return, ptr. ptr is non-type template parameter. Why ptr is called non-type template parameter? It will be clear. Void test non-type template parameter. Stream get a value. Please note that we are passing this global variables address, and there now I copy this function, pasted it here, and I disable it. Please note that we declared a global variable here and a template function that takes pointer, integer pointer, and we return value of that pointer, and we call this function using global int address. Okay, now let's build. Hit enter. It works successfully. Now there's something wrong. This is the address of this function. So I say the address of function. And the correct way, if we want the value, then we have to do this. The returned value of the function. Don't forget parentheses here. Okay, so I fixed like this. Then compile again. Okay, it works successfully. Okay, the address of a function. This returns function address, and this returns function return value. So it works successfully. Let's try another one. Template auto ptr auto get a value using auto. Now here return ptr. I generalize it. Void test get a value auto. Static double d 22.0 divided by 7.0. Okay, please note that this is static stream. The value of d, or I will not initialize it here, then I will initialize it like this: 22.0 7.0. Here we call this function like this. We pass address of d and there. Okay, now we are calling this function. Now let's try it if it works. Yes, it worked. We have to call this function. Copy, paste. I disable it. Why is squiggle? Now let's try it anyway. Okay, it compiled successfully. CLS. The value of d is displayed properly. Why it works? Okay, why it works? Let's think about this. In this case, this is a global variable. The address of any global object is evaluated or determined at compile time. Global and static local variables are stored in the data section of the generated binary code. Memory for objects in data section are determined or allocated at compile time. So in this case, this is static. The address of the is determined at compile time because d is specified with the keyword static. This code is executed at runtime. At runtime, we can get the value of ptr. So this code works. Void test failure case double d 22.0 divided by 7.0 string the value of d get a value. I will copy this function and I will copy this and paste it here. I will build once again. $102. No, it does not work. The reason is here. The address of the local variable residing in the stack is not determined or evaluated at compile time. We can know the address of a local stack variable only at runtime. So we cannot pass non-compile time expression as non-type template argument. So this line of code does not work. Okay? If I disable it, it works. If I enable it, it does not work. Okay, I will disable this part. Before I close this episode, I will give you another example. I think this example is very important. Void important concept for compile time expression. In C and C++, the enumerators of an enum are compile time expression, std, tuple, int, double, constant character pointer. Okay, I will define a type using tuple t. I defined like this: enum size t, age, weight, name, tuple t, person. We can initialize like this. Age will be 20, weight will be 60 kilograms, name is Thomas Kim. Stream, we can access tuple like this: I am std get name, person, I am std get age, person, years old, I weigh std get weight, person, kilograms. So I copy this function name and paste it here. I disable it, build once again, CLS A. I am Thomas Kim, I am 20 years old, I weigh 60 kilograms. If we look up this here, std get, it is tuple get. This size is constant expression. This is index. Okay? Extract ith element from tuple. It must be an integer value of the range. int index 0 stream std get index. I will change it to size t, person, and there. This code does not work because the value of index is determined or evaluated at runtime. Index is not a compile time expression, so this code does not work. Okay, it does not work. Now I will fix this. I will fix like this. Now it should work. Another very important example, void why it fails. Here, using variant t, std variant int double constant character pointer. I defined a variant t item. I can set item. For example, integer is allowed, so 5. String item std get 0 item, and there 0 means the first index, so this is integer. I copy this function, I disabled it, I build once again, CLS, it works. Now I will give you another one, item Thomas Kim stream std get first 0 1 2, so we have to provide 2 item, and there it will work, but it does not work. Stream std get item index item, and there, well, you can say size t or auto index item index. We cannot do this. This code does not work. This code does not work. I will run it. No, it does not work, because this is compile time construct. The value of index is evaluated at runtime. Non-type template argument should be compile time expression. So the value of index is not determined at compile time. So this code does not work. Okay, this code does not work. But you can do this. Stream item, and if we run it, it built successfully. This part of code runs successfully, but this does not work. This does not work. Okay? Then you probably wonder, I will disable it too. You probably wonder how I implement this stream class. How can I access the value of variant properly at runtime? At this point, you should wonder how I implemented stream class such that it can figure out the type of item at runtime. The answer is template metaprogramming technique. And watch type function programming and template metaprogramming. You can understand how I implemented through this series of videos, 30 videos, and template metaprogramming. Through this series of video, I explained all about advanced template metaprogramming. Please don't fail to watch these series of videos, and don't fail to watch this series of video, type function modern C++ programming. especially later part of these videos are more important. I explained why you should be extremely careful when using std command type. Please don't fail to watch these videos. The concept of a compile time loop. I explained type list and compile time loop beginning this video, episode 24. These concepts are very important if you want to know advanced template metaprogramming. Probably I am the first person who teach about type list. And type list compile time loop enables you to create very powerful and complex C++ class and algorithms. I will post complete source code to my website extension talkplayfun.com website, and I will post complete source code. Click this button to download complete source code. Show in folder. If you unzip this folder, in CPP extension tutorials folder, you can find the complete source code of this episode. Also, if you are new visitor to my YouTube channel, click this link and install latest version of Microsoft Visual Studio. Also, watch this video to install latest version of GNU G++ and Clang compiler on your Windows. Then you have to make proper system environment variable settings. By watching this video, make proper system environment variable settings and make command prompt. Otherwise, you cannot follow this episode. Please subscribe to my YouTube channel. Thank you for watching.